Okay, this is an exam style question. We've got parametric equations, x and y, and it starts out very gently. Find dx by d theta and dy by d theta. So they're using theta instead of t, we don't mind. So dx by d theta. I'm going to do it up here because I don't know how we're going to work out for space, and you can see the equations clearly. Dx by d theta, differentiate cos theta, we get minus sine theta. Dy by d theta, differentiate sine 2 theta. So it's sine of a constant times theta, so sine will differentiate to a cos. Inside the cos I'll still have 2 theta, but as we know, because there's a 2 in front of the theta, I get a 2 popping out in front of the cos. So I've got dx by d theta and dy by d theta. Okay, so for A2, that's where I'm going to actually start using the proper answer space. In an exam, don't do this. Write down all of your answers have to be in the lines. I'm just trying to save a bit of space. Find the gradient of the curve at the point when theta is pi by 6. So actually, I could deviate from what we've been doing. I'm going to be looking at dy by dx. And I know I have to do dy by d theta, in this case, not t, over dx by d theta. Okay, what I could do is actually put the pi by 6 into these things before I do the division. But generally speaking, it's not a bad idea to always stick to the same process. So I'm going to do that. I'm going to stick to 2 cos 2 theta on the top and minus sine theta on the bottom. And then say when theta is pi by 6, okay, we're going to have 2 cos of twice that, which is pi by 3, over minus sine of pi by 3. And they've been very kind in terms of choosing this angle, pi by 6, giving these two, pi by 6 on the bottom. Because sine of pi by 6 is very nice, it's just a half, as your calculator will tell you. And on the top, make sure your calculator is in radian mode, of course, if you are using your calculator. And then cos of pi by 3 radians is also a half, so it's 2 times a half divided by minus a half. So the answer is actually just minus 2. That's the value of dy by dx. What was I asked for? The gradient of the curve. That is just dy by dx. So this minus 2 is my answer. Okay, and then we've got to do part B. What does part B ask us for? Part B says show that the Cartesian of the equation of the curve can be written as this. This is nothing to do with differentiation. So the part B is what we call a re-entry point. Okay, even if you couldn't do part A of the question, you can come straight in. And notice it's a show that question. So we saw show that's of Cartesian equations. What we're allowed to do is start with the equation as it's written here, which has got y squared in it, it's got an x squared in it, and it's got a 1 minus x squared in it. And effectively, if we find k without cheating, then we're allowed to use this equation as our starting point. So I'm going to look at y squared, and here's what y is, and I'm going to look at x squared, and I'm going to look at 1 minus x squared. So start off y squared. Y was defined in the question as sine of 2 theta. So y squared is sine 2 theta squared. Okay, well let's just leave that for a little while. I've got to look at x squared and 1 minus x squared. And x was defined in the question as being cos theta. So x squared is cos theta squared. And so 1 minus x squared is 1 minus that. Cos of theta squared is cos squared theta, of course. So this is going to be 1 minus cos squared theta, which of course is sine squared theta. So, okay, I've got cos squared theta, I've got sine squared theta, and that's got to somehow be related to this. So this has got the double angle, these don't have the double angle. So we've got no choice about how to simplify sine of 2 theta. It's got to be 2 sine theta cos theta. And of course you could have done this bit straight away, all right? But there's no harm in seeing where you're heading with the other bit and then just deciding what decision you have to make. Okay, but we do have to use a double angle formula. And when we simplify this, 2 squared is 4, so it's 4 times sine squared theta times cos squared theta when I square everything. Okay, and I wanted the equation to look like, okay, where is it? Y squared is a constant times x squared times 1 minus x squared. Well, we've got y squared equals 4 times sine squared theta times cos squared theta. Well, sine squared theta I now know is 1 minus x squared, and cos squared theta is clearly x squared, and I've got a 4 in front of that, and so I've got y squared equals 4 times x squared times 1 minus x squared. So this is exactly what we wanted. So basically the constant k equals 4, but that's almost in brackets. This is my answer. And although I've actually got there by using this as a starting point, on a show that question with a Cartesian equation from parametrics, it is okay to do this. So this is a perfectly acceptable solution, and that would get full marks.